Everyone, welcome to this week's edition of Water Talks. I decided to take some time and we'll take a look today at converting some XP or one XPSWM model into ICM SWM and just give you a feel of what kind of that looks like and things like that. For those interested in doing that, as we advise and Autodesk kind of centralize on ICM being our storm sewer flood solution. Your host today is just me. My name is Ryan Brown. I'm a systems engineer with Innovise. So not too much to go over there. So if you haven't been one of these before, we've been doing them for a while, but if you haven't been to one of these before, it's a pretty simple concept where we're really just trying to interact with our users and different things like that, and give them a forum to be able to ask questions. And so any kind of questions or even just comments or things like that you want me to see, it is just me. I'll just try to manage as best as possible the questions, but I do have a couple of screens, so I'm able to monitor the question block and see those as they come in. So some of the upcoming water talks that we have next week, looking at just some water distribution, look at just the best ways of being able to model and tips and tricks kind of thing, and then also then following week looking at what's new in our cloud SaaS platform Info360 Insight and some of the connections there. So part of the other reason that this kind of came up and what this stems from is I think it was November of last year, we kind of went through what's new in ICM, newer things that we've added. Within that, there were a lot of things XP related and also ICM SWM related to make the functionality much better with the ICM platform and some of those interactions with XP. So just highlighting some of the things that are able to now be used within SWM networks within ICM, and some of the export and import routines into ICM, but just being able to add in certain things like flood types for being able to do 2D simulations, 2D modeling in general being added, and that's the example that I'm going to go over today is a 1D, 2D model for being able to do that, importing a lot of objects through that XPX file that you're able to get from XPSWM. Of course, boundary types are always important for being able to properly model things within a 2D system. And then probably one of my favorites in a huge acceleration over some of the performance and some of the thought in the classic XPSWM licenses, where it's just able to use the CPU. There is a GPU add-on, but a lot of people don't have that. InfoWorks ICM and the SWM engine within it automatically comes with that capability. So being able to speed up the simulation can be really beneficial. And I've got a slide after the live demo to be able to highlight some of those time differences between a classic XP run versus some of the different options for adding in GPUs and things like that. So with that, there's not a whole lot I wanted to go over there. I think I mostly wanted to focus the time on the live demo portion of things. So this is the model in XPSWM that I was planning on converting. It is a 1D, 2D model where I guess we can look at the grid extents there for how much this covers. There is a 1D channel in here that connects into an underground network, and then the banks of these areas are connected to the 2D mesh to be able to show that. So really the first step starts here where we're going to export out the XPX file or export out the XPX file, and we're going to select everything that we can export out so we can make sure that as much as possible is going to be transferred relatively quickly and seamlessly. I've already done this, so I'm going to hop over to InfoWorks ICM at this point, where I have I have completed the demo that I've done, just in case I run into any hiccups or anything like that. But the intention is to kind of walk through the process of building out these things. So within the model network build, we're going to go to importing into SWM, the model group, and you can see here we have from XPX or from XPSWM, and we're looking for that XPX file. So like I mentioned, I've already got that exported. And this does take a second to fully come in and bring everything in, which is probably a good point to say, you know, it's not, while it would be certainly ideal, and we're certainly working towards the capability of, you know, just having that export into an XPX file and then bringing everything in and everything's going to be perfect. It's not quite there yet. This kind of felt like I struggled to make sure that, you know, this would be a good topic to talk about, because there are some bugs and things like that that I found as I walked through this process. But you know, with the next version of InfoWorks ICM, many of the bugs that I kind of go over and show are going to be fixed, or or functionality in the future, things that are roadmapped and planned are certainly going to be added in as well. So we're definitely getting to that point. It's not quite there. There's also some TV magic, as I call it, that, you know, it's, instead of tediously watching me do something, I've kind of baked some things already in. But, you know, for the most part, there is a lot of things that come in, including things like the rainfall event. All of these things, it's, you know, a good idea to just check on and make sure that these things came in right from the XP model that you have. Being able to view things in here, and then just kind of verifying that things are coming in correctly, and tends to be more of a spot check kind of thing, and making sure those that things come in. The other big thing that is going to help is the validation, which will go through and validate the model a number of times and find some things that would be messed up. First thing is the rain gauge always just comes in at 0.0. So I'm going to change it just so things are a little bit closer. I've already got some coordinates written out on another screen I'm looking at to be able to just bring that all in much closer. So every time I open up the model, I don't have to zoom around and zoom in and things like that. But that tends to be a pretty simple fix there. The next thing that I'm going to bring in, so there is a surface within the XP file. So you can, you know, export these out into and create a, you know, create an ASCII file that you can then bring into here. There is also some TIN files, so you can bring in like an XP TIN file. I've got an ASCII file. So that's what I'm going to use in this simulation first, and so that tends to be a pretty simple process too. I'm just going to name it DTM for sake of simplicity. This is a model that was originally developed in the UK, and as a result, it is in meters. So my units for my ground elevations and my coordinates and things like that are in meters. So I just switched it to that, but hopefully it's, you know, projected and everything like that in the correct way. If I hit OK here and drag it on, I can make sure that that's going to show it. That shows up in the right spot. So I'm able to use that pretty easily. Just going to turn off the view of it so it's not in the way. Yeah. So I guess another thing to just kind of think about, there are within the options, you know, the capability of setting the map coordinates. So there is that capability in case there's maybe things that are mismatched or something like that. It's always kind of tricky a little bit to be able to make sure that things get shown up in the right spot, especially if they're not correct in the XP file. And I highlight that because and there's some things you can do, to manipulate the coordinate systems and things like that. If you were to say export out the land uses to a GIS file and then correct the projection or something like that within a GIS platform like ArcGIS Pro or ArcMap. I highlight that because these roughness values didn't quite come in the right way. They came in as forest polygons, something that we'll be able to fix in future versions. But there's really two options for being able to fix that. The first one, and probably the easier one, is to just export out into a shapefile and be able to bring that in properly through the Open Data Import Center. I didn't have the luxury of being able to do that because once I exported out the shapefile, I had trouble getting it to project in the right spot and it wasn't coming in. So instead of doing that, I just pulled up the polygons window. I went through and just selected all of my forest polygons here. If you right click and go to the selection and selection operations, there is this change polygon, so I can just quickly change it, all those into roughness zones. So all those got changed quickly and easily. We don't have any more forest polygons in here, and those are all in the roughness zones. The bad thing with doing it this way is we still need a Manning's N, and by being able to export out into a shapefile and having that data within the shapefile itself makes it a lot quicker and easier. Like I said, I have some stuff already kind of cooked in here, so instead of spending a whole bunch of time trying to figure out which roughness zones are which, I just have a Excel sheet over on the right side of my screen here to be able to copy and paste a lot of this data in rather than having to spend a bunch of time being able to be able to pull anything. Looks like we have a question real quick. I might as well stop. How would you go from importing a 1D, 2D model from ICM into XPSWM? Is it possible to export a 2D mesh from ICM? The answer is no, and we don't really have great routines for going from ICM into XPSWM. The whole idea is more of a shift towards ICM in general. The only export into model type is the SWM5 file, more of just a standardization on a type of network to be able to export, say if you have clients or something like that, to be able to show them that information. I guess in a similar vein, there's not a one-to-one relationship with the 2D meshes, because if you weren't aware, the mesh within XPSWM is a fixed mesh where you're simply, we go to the property, setting the grid cell size and then some other parameters to be able to define what that mesh is going to look like, and it's a fixed ridge. There's some add-ons to be able to do multi-domain where you can do different degrees, and then also the quad tree to be able to split up and have different kinds of sizes to the mesh, but it is a fixed grid versus ICM is a flexible mesh. And once I mesh the 2D zone, it's kind of towards the end that I'll show you how it's more of a flexible mesh rather than a fixed grid like the XPSWM has going on. Got some other questions coming in, but I'm gonna hold off and keep going, and maybe some of them will get answered in a little bit. And somebody's having trouble hearing me for whatever reason. That should be better. I changed my sound settings. I'm so sorry about that. For whatever reason, GoToWebinar likes to pick my computer's microphone rather than my headset microphone. So hopefully that clears up that issue. Another thing that I ran into, so as I'm looking through and reviewing some of the data, I noticed that the flood type doesn't get populated for the nodes here, so that's again a pretty simple fix. I know not necessarily ideal, but you know, I know all of my nodes within my are within my 2D area and should be connected to it using the 2D. So I can just do a bulk edit, be able to fix that relatively quickly. The other big thing that disappointingly doesn't come in is the subcatchment information or the runoff information. The good solution to that is to basically just export out the nodes into a shapefile. And within the nodal information, there are runoff information associated with it. So by being able to export out this into a shapefile, I can then come into my ICM SWMM network and through the Open Data Import Center, which takes just a second to come up. This is where we're going to bring in that subcatchment information, and it's not really going to draw anything. It's not going to like be physically represented on the plan itself, but will be in the database. So there's, you know, I guess maybe good and bad with that. But here's the file that I exported. I did already have a configuration file set up, so I've instead of having me go through and make sure everything is right between the two, I've just made this configuration file, which is going to set things based on my shapefile itself, and then I've also got some default values because in this case, all of the impervious areas, the pervious areas, all the percent storage, all the Horton information, that was all the same for all my runoff nodes. So if I just hit import, it's going to bring all those objects in, and then I can go look at my subcatchments, and you know, of course they're in now. So from there, that was, you know, bulk of the review and things that I caught that were in there. I will say too, it always depends on the model. It depends on what you're bringing in. I did this complete quads one too as a part of kind of preparing for this whole thing, and there were some different things that happened that I'm not necessarily going over here, but again, I think through just going through and kind of spot checking things, making sure that things make sense, and then also the validation will really help. So if I go through the validation, I definitely do have some things that came in incorrectly. So since I exported out the subcatchments as nodes and I just did all of them, you can see that not all of the nodes have runoff information. So there's a couple in here that have a 0 area, which is why I'm getting that error there. You know, it's not really a big deal because I can just sort the area based on the ascending value and then select all those and delete them out to clean that up pretty quickly and easily. The other thing, duplicate objects with the outlet name. So for whatever reason, in ICM SWMM, if I have the subcatchment ID the same as the outlet ID, it doesn't like that. So the solution to that is create a nice little query. So pretty easy to set these up. I'm gonna name this change subcatchment name. And if I pull up the dialog here, I am going to interact with subcatchments, and I'm just gonna say set subcatchment, oops, ID, which is the field name for the subcatchment ID, equals subcatchment ID plus 0.1. So basically what I'm doing is just taking the existing subcatchment ID and adding 0.1 to it. I can test it to make sure that it's okay, and then I can, whoops, I'll save it first and then run it. And so you can see now my subcatchment ID is updated with 0.1, and if I run the validation, I do get rid of those errors. But on to the next one. Here is that the junctions within here are flood type 2D, but there's no TD zone, simply because I haven't meshed things yet. The other thing that I'm going to do, so if I look at the ground again, it's not in extremely high detail, but instead of having to keep these 1D channels in, I'm just going to delete them since they are represented in the DTM. Turn that back off. So I'm just going to quickly go through, select all these, select all these channels in here and delete them out so I don't have to get them connected to the 2D mesh and stuff. And then the other thing that I like to do, if I am doing a 2D mesh and having it spill into the channel like that, is to create mesh zones or mesh level zones around these. In an InfoWorks ICM network, I would normally use a mesh zone, but it isn't fully built out yet. To be able to allow me to set the elevation of the mesh level zone. So I'm going to use mesh level zone for these, and there's only a couple of them. So I guess kind of bear with me in terms of being able to set all this stuff up. But these can be pretty easy, and I've already looked at the node information, so I know the elevation of that node, and I'm just basically creating a zone around it to be able to have the elevation of the cell, make sure that the elevation of the cell is going to be the same as the elevation as the node. Sometimes they can be subtly different, and like water won't get into it correctly. So this is a good way of being able to set up these areas. I do like to use triangles. If I had already meshed the 2D zone, I could be able to set the or make the triangle roughly the same size as my mesh. That's typically another good practice to be able to make sure that the elements we're basically creating, the triangles that we're creating, are going to be a similar size to the ones that we are creating in the mesh overall, just to have some kind of continuity to them. And there's just one more, so hopefully this isn't too tedious watching me. 5. Okay. Yeah, so we have that. The next thing that we're going to need is boundary conditions. So in our XP model over here, we do have upstream and downstream boundary conditions. Up at the top here is a user inflow file. Down at the bottom, there is some level information associated with the downstream area. So that's the lines. It's somewhere in here. No, I definitely pulled it up before, but there's some level information in this downstream side of things. I don't know why I can't remember where it is, but anyway, just maybe trust me with that one. But there is some level information down at the downstream boundary there. So these do need to be on all the vertices, so they need to be overlaid on the 2D area, or else we'll get a validation area bound downstream boundary. And then up here, getting the upstream boundary, which I always have trouble finding the vertices. I know there's one in here. Ugh. Maybe I'll just do it to here and hope for the best. Or maybe I'm remembering incorrectly. Oh, no. I don't know why the vertices aren't showing up. Well, no, maybe there wasn't one there. Oh, there is one up there. All right, we should be good now. Yeah, so this upstream boundary is going to be an inflow file. So we're going to create an inflow file to basically mimic what we already have, and then the downstream boundary is going to be a level boundary. Let me double check on my notes. Okay, so looks like we're good with everything there. So within the XPSWM file, the upstream flow, oops, gosh, I'm gonna turn off my grid so maybe it'll pan a little better. Looking here, I would guess from some kind of data manipulation, but you can see that we don't have quite an even distribution of time steps. So basically what I had to do there was find a time step within ICM to kind of match everything. So when I go and create the inflow file, name it upstream boundary. So if I go and set the properties here, the time step basically that I found out was a 36-second time step, and then I did some interpolation between the times to be able to correct everything, kind of normalize things out basically. So like I said, I've got an Excel file with some information. I'm also going to update the start date for this because SWM is a little more on the, setting a start date and time in the simulation. So I know that my start date is the 1st of January 2014, and then the start time is 2014. So if I hit apply, and then I just paste in and then add additional time steps, I'm able to pull that full thing in. I know it's a 4-hour simulation, but the flow file within XPSWM it does end roughly the same time. If we go and look at that 3 hours and 0.33 there. So last thing that we need to do is make sure that we're referencing the same thing by just calling it the same as the as that upstream boundary named. So that's where we do all that. If I close it out, I save the changes there. The next thing that we need to do is create that level file. And so if I do downstream boundary, and similar idea here, this one's a little simpler because the level is constant through the whole simulation. So just to match what I have, I'm going to name this so it's referencing the correct thing. It's referencing that downstream boundary line. And then in the sub event properties, again, changing the start date and the start time so it matches up with my simulation. And then I'm just going to do 5 hours, so I'm covering the whole thing if I hit apply there. That downstream boundary is at 114.829. Don't necessarily need to take it out that far, just trying to mimic what we had already within XPSWM. So you can see, since I picked the 5-hour time step to be able to, that I just need to put in 2 values there. So close that, it's going to save everything. The final thing, or not the final thing, but another thing that I need to do is make sure that the, oh, and before I do that, so I don't have to mesh twice, if I validate, so it says that drainage system has no acceptable outlets. Well, that's because this is a full 2D simulation and I don't have any 1D links going out of it. You know, we can fix this in future development, but for the time being, the kind of workaround that I came up with was just create some dummy link here. So I can specify that I have an outfall going from my 2D zone out to my 1D zone. And then if I set up a link between those two, I hit OK. I'm just going to put in some random information because it doesn't really matter as far as, and just trying to meet some of the validation criteria. And then the other thing I can do to just make sure that no water gets into here and messes up my simulation, I can create a porous polygon around that and then keep the default infinite crest and never remove the simulation. So even if water ponds up against that, which it's not likely to based on what I know from my XPSWM simulation, but in this case, we're able to block anything that gets out into there. And if I hit validate now, that error does go away. So the last one that we really need to take care of are these this junction, which is related to the fact that we haven't meshed things. So again, the grid doesn't come in the same way from XPSWM just because it's a different type of mesh. But I do want to adjust these. And after kind of tinkering around with it, these values that I'm putting in here seem to be at least pretty similar in terms of being able to produce the same number of cells to get that same level of detail as I had in my XPSWM model. So and I'm going to change the Manning's roughness. So besides these areas that were already defined, I need to set a default value within XPSWM. That's all within the 2D run simulate properties. So you can see here that my well, if I could find it, it's somewhere in here. That my default is 0.06. Maybe it's in the properties. Anyway, regardless, it's 0.6 from my notes that I have. So we're just going to hit that so that every area that isn't a roughness area is going to have the value 0.06 as its default value. So if we select the select the 2D area, go up to model and meshing, we have represented the buildings as roughness areas. So it's just a really high Manning's roughness, different philosophies and thoughts around how the best way to bring those in, but you could certainly create a polygon file and put them in as voids or put them in as walls or something like that, or leave them as porous polygons like they came in. But using the DTM that we have, pretty quick meshing routine to be able to do that. And if I load up the mesh, there we go. So we've got our whole model here. Validate to make sure that I've covered everything. Don't have any more validation properties here, so I'm going to just say this is the initial import and hit OK, commit all that stuff to the database, and then we can go look at our simulation run. Good to check this type of stuff. This is a bug that I found and I know is going to be corrected in the next release, but the time for the analysis didn't quite come in correctly. If I go and look at my parameters here, I've got that this is running for 4 hours. and it came in that it's running in 4 seconds. You'd probably quickly realize that if you did run the simulation and it ended really, really quickly, you'd realize that you need to expand that. So everything else seemed to come in correctly, routing time step and all that kind of stuff. So if I just hit OK, the other thing, and I think we should be getting this fixed too, the default in an ICM network recently got updated so that the GPU card is used for 2D simulations if the card is suitable. The default in SWM networks is still never. So make sure you switch that on so you're taking advantage there. Hit OK there. I've got my rainfall information. The SWM climatology came in correctly, and then also my SWM network already populated. You do have to press the update to latest to make sure that that comes in, and then just drag over the level and inflow files that I had set up earlier, and then run the simulation. So that's basically the process in a nutshell. I'm going to go through and answer some of these questions that have come in, and then just kind of show the process of getting into an ICM network from this point, which is a lot quicker and smoother than necessarily bringing it in from a totally different modeling package. So going into some of these questions, have you seen any typical issues or bugs running 2D SWM models? Any easy fixes or workarounds? That person's left anyway, but hopefully they were able to glean some of the information from just walking through, and some of the things just to look out for, using the validation tools and being able to use that to your advantage and make sure that things are coming in correctly and things like that. Got a comment from Bob Dickinson on our support staff. The ID problem that I showed earlier with the subcatchments having the same name as the node that it's routed to is a SWM-5 rule. So that is the reason that it has that issue. So not an issue in ICM networks, but a SWM rule for SWM-5. So have some questions and comments about SWM, EPA, SWM engines and things like that. So XPSWMM uses an EPA SWM-4 engine. Kind of the history behind it was really that it was a GUI for SWM-4. It has been significantly enhanced, and I know some of the routines and things that have been added to it were kind of carried over in part of the inspiration for the SWM-5 engine. And that's part of the reason there are some of these issues of having to tweak things and fix things. There's also issues with the XPX file itself to be able to make sure that that's written correctly so it imports correctly. So it's not necessarily ICM's fault. Some of these bugs and things come up. Sometimes it can be XP, and then also just being able to translate from an earlier engine type to a later engine type, which ICM SWM uses the 5.1.015 engine, and it has been tweaked a little bit and changed to enhance it. One big key difference is that in SWM-5, just EPA SWM-5, you can't route multiple links to an outfall versus in the one SWM engine that we have within InfoWorks ICM, you can have multiple links going to one outfall rather than having to do some workarounds or something like that. Oh, well, but yeah, so another comment from Bob, having a single orphan outfall should allow you to validate. So we can, I guess, do some on-the-fly testing here and just delete out some of this stuff. Delete and see if that'll work for us.
and then delete. Let's validate and see if that'll work. Yeah. Oh, no, porous polygon. Yeah, so I deleted that porous polygon. So looks like that's probably a better workaround. I'll remesh it just for the sake of making sure that we can commit everything to the database. But that seems like a much better option instead of having to do all that work to, I mean, it's not, I guess, that much more work, but having an orphan node as an outfall would allow another workaround to be able to not have to walk through all that stuff quite as tediously. So let's validate, make sure that an orphan node's not going to give us a problem either. Yep, so we're good, super. Yeah, so that'll be a much better way of being able to work around that just by having that functionality. I can hit commit here. So one final question to go over before looking at maybe what this looks like in ICM. Do break lines need to be added in the channels to account for flow lines and channels, or does the mesh already capture that? To some extent, you know, it's going to be nice to be able to give a little more definition and things like that. The other thing that I know is going to be released in the next ICM release, which is in the next month or two, was terrain sensitive meshing wasn't carried over. The 2D engine in the SWM network is the same one as the ICM 2D network. So, you know, it was just something that they just didn't add in, but easy to add in, so it's going to come out in the next release. But by using the terrain sensitive meshing, you could do a lot better job of quickly giving more definition in some of those channelized areas where there's a lot of the topography change, rather than having to put break lines and stuff in. But certainly that's a good practice to be able to do that and show that. With the level of detail that I have in the mesh, it seemed to be okay. So, and just for demonstration purposes, I figured it would be fine to just show like that rather than spending time putting in those break lines and things like that. Of course, if you have them in here, that would be, or there's not the capability of adding those in here, but if you had some objects or something like that for like the stream channel definition or something like that, you could bring those in pretty quickly and make some of those definitions a little bit easier. Yeah, so from there, let's look at what it looks like just to, if you wanted to do some like comparison type of stuff, in ICM to be able to do some of the conversion process, and just to kind of save, I'll show results, but just to save on my processing power, just stop that for now. So like I said, there's not nearly as much work bringing these into a ICM network once we do get it into the SWM network. So we do have that option of quickly being able to convert these once we have them open. Oops, just dragging that over and then into my ICM network. And then Zoom 2 network. So in this case, it's a little better in terms of being able to you know, it brings in the whole mesh and things like that. Like I mentioned, it's the same engine, so why not bring in the mesh and all that. So I'm gonna hit validate to see what we got going on. We've got a bunch of links that are not connected to the outfall, and the real problem here is actually with the nodes. For whatever reason, just another small bug or whatever, the flood type gets imported as lost. And of course, since we're doing a 2D simulation, we want to switch these all to 2D. So just bulk edit, switch all those. Not a huge deal. Not ideal, but not the end of the world. So hitting validation, we've we've got a node, it's just a warning, so we can still commit everything and use it. That's my outfall, it's not connected to a link, but no issues there. So if I hit save, hit OK, from there, that's pretty much all there is to it. Whoops, meant to hit run. I can create a new run and then set up my parameters just like I did for swim as ICM. Whoops. Drag that over, make sure my starting times and stuff are updating correctly. Do it for 4 hours. And then I can use a lot of these same objects in here too. So the level information that I created, the inflow, the rainfall event that came in, all of that can be used in my new simulation here. So yeah, good question about how are the 1D, 2D connection and interface lines from XP brought into ICM. So the idea, or the truthful answer at this point, it hasn't been developed yet. So we don't have the same capability quite yet within the SWM network to be able to make 1D, 2D connections. So that was another reason that I just simply deleted out the channels. So instead of having to one, make those connections, but two, right now it's not quite possible to be able to set things up in the same way that we have them in this XP model, where we have a one-dimensional channel and then we have inactive areas over those 1D channels, so we're not double counting for the amount of conveyance in those areas. And then as it reaches the banks, it spills out. You could do that within ICM, and it is a very similar routine that you go through in terms of defining out, the 1D channels and bringing all that information in, and then being able to set up the banks and the connections with the 2D areas. It's fairly similar in being able to use exports from the XP model into GIS shapefiles. The boundaries of those 1D, 2D interfaces and connections can make that a little more of a seamless process. Yeah, so I'm going to cancel that one too, and just go into where I have these completed already. And these are exactly the same in terms of their in terms of the solution and everything. So so yeah, pretty similar results that we saw within our XP model. Some subtle differences and things we need to pick up on between the two, but between the ICM network, between the SWM network, you can see I didn't correct the rain gauge information there, so I have to do some zooming in. But you can see as we toggle through the simulation and then just looking at kind of a comparison to the max here, fairly similar in terms of the inundation and where things are flooded and things like that between the two there. The last thing that I was going to highlight, going back to the PowerPoint, are some of the time differences between each one of these. So just, straight up doing some testing between each one of these models and looking what it looks like in the XP took, almost 30 minutes using XP Classic, which many of our clients use. We were able to cut that down a little bit using the cores, but it's really the GPU that's going to accelerate things, and the XP with the GPU add-on compared to, I think if I took this down to the decimal or put some seconds on here, it's subtly different between the ICM networks and the XP with GPU, but they're pretty much the same, and it's largely because of the GPU. Similar idea here with the ICM SWM network versus the ICM network. There's not a whole lot of 1D calculations going on, and since it's using the same 2D engine, it's to be expected that you'd be able to be able to, have a similar time there. Got another question. Tried importing a time series files into InfoWorks ICM, but was not successful. Upon reaching out to support, they told me to first convert it into a CSV file and then import it. Is that true? I can only assume that it's true. I'm not sure if you're talking about like a time series database or if it's just like an inflow file, like I was showing earlier on the upstream side here. This information doesn't come in when you import the XPX file itself. And that's why I recreated things into my spreadsheet. So this was the spreadsheet I was copying off of. And there is some, trickery, I guess, or Excel magic that you can do to be able to make sure it's looking up the correct value. Without having to do a whole bunch of manual work, even though the time step between here, as you can see, it's not quite even through each one of these. So that's why I had to kind of expand things out and then do some interpolation between values that I didn't have great information for. Time series rainfall from SWM5 files. Yeah, I think that's what support has suggested for you to do, to bringing in the time series rainfall data. Yeah, I would do some Excel manipulation and do some tweaks there rather than necessarily relying on bringing some of that information in, especially if it's just from a SWM5 file. We have the advantage with XPSWM of exporting out the XPX file that has a lot of the, I guess, ancillary information like the climatology and the rainfall file. Not everything gets transferred that way, but for the most part, yeah. Follow up on the 1D, 2D. What workaround would you recommend for a culvert crossing or inlet that is wider than the mesh, wider than the cell without making the mesh larger? Oh, and I'm sorry, got some clarification on the time series. So back to that real quick from Bob on our support team. The time series files are not imported, but time series are imported directly. I need some more clarity on that. I'm not sure. I think we're getting into the weeds on the particular instance and things like that. I would certainly go with whatever support has suggested that you do is likely the method that you should go with. But going back to the what workaround do you recommend for a culvert crossing or inlet that is wider than the cell in ICM without making the mesh larger? I'm guessing maybe that you want to add in a, whoops, go back to my ICM model. So maybe in this case, so this is a culvert here underneath a road crossing. Guessing you're meaning that the mesh cell size is larger than the culvert itself. I would use these mesh zones or mesh level zones in a very similar way. So if you do create a mesh zone, you can override the maximum triangle area and minimum element area here. So you can basically use these to add in more detail in certain areas. So instead of applying to the larger mesh and potentially slowing down things, you could override the minimum element area and add in some more detail where that mesh is. Okay, yeah, I guess with that, I mean, that was all I really had to share. Hopefully it was beneficial. I know we're a little bit early, but we don't have any more questions. So Yeah, I got some questions coming in just now for the recording of the webinar. This is being recorded, and we have, I guess with the new year, started to send it out to people who have registered or people who have attended as kind of a follow-up email. So you should receive an email in the next day or two with a link to where that is. Of course, you're always welcome just to look on our website. Under resources, there's a tab for virtual events and webinars, and that includes both on demand and current ones, just like this one. So you can go back and find really most of the water talks, I think, get posted on there. So you can just scroll through there and look for ones you may have missed in the past as well. So yeah, I guess with that, we'll call it. Thanks everyone for joining, and hopefully that was beneficial to everyone. But we'll see you next time.